Everybody, hey, okay, so everybody's here. So we're going to talk about a Python journey today because Python's cool. And it's going to start out a little bit with the very easy parts, what is Python in case you really are in the wrong place. But it rapidly becomes a little bit more interesting. So the obligatory, this is me, yes, I'm looking, etc. Okay. So we're going to go through a journey of Python, and we're actually just going to look through a very small section of it. This is a little like going on the European tour in 7 days. So we're going to just stop, take a look at a couple of topics, and move on. I want to try to give you a little bit of a mental map so that when you say, oh, I want to learn about this, you know it exists, and you can kind of put where it's going to exist in the rest of the world, as well as just get a scale. I mean, Python has hundreds of thousands of people, and they all develop code, and a lot of them share that code. And they form communities, and they make groups. And after a while, there are a lot of people doing a lot of things in Python. And it's big enough that you can't keep up. You can't say, oh, well, I'll just learn all of Python. No, you get your interest, and you can go forward and learn about that interest. This is to give you a little bit of a map of what's out there so that you know when you have to reinvent a wheel and you know when there's 500 to pick. So we're going to start off in one corner. I'm going to call this the land without code. So this is the subject before we start going into the world of code. And we're going to start off with, what is Python? Because that's the first part of any journey. Well, Python's awesome. Actually, Python is awesome. When you talk to developers that have moved to Python and have programmed in a dozen or so different languages, people will tell you uniformly that Python is great because it allows you to express yourself concisely and save developer time. It's one of the only languages I've ever seen where saving developer time was a key aspect of the language design. Usually, for example, when I was at JavaSoft, and Java was made so that we could push it out to domain experts and scale it up to 10,000 people. We never thought about, oh, should it be fast for the developers to use? Should it be easy to look at the code? Should it be easy to express yourself? No, it was all about, we had some business concerns. And the same with other languages. There are either machine concerns or business concerns around it. But it expresses the programmer intent concisely and accurately. A lot of people will do experimental programming in Python even if they have to code in another language once the platform's up. Now, Tim Peters wrote a 19-line little poem about this, what's called the Zen of Python. And it was the first language I've seen that really set out what its trade-offs were. So here's the first line. Beautiful is better than ugly. There's not going to be anybody disagreeing with that. But it's trying to inform how your APIs and how your code should look. It's also one of the very few Easter eggs in Python. So if you're in the console and you type import this, you should go ahead and read it. It's only 19 lines. But it gives you an idea of how we're making these trade-offs going forward. And one of the trade-offs that is really important in Python is that the language will fit in your head. You can kind of take this Python language and shove it in, whereas, how many people can really tell me whether or not C++ functions are supposed to overload on const or not overload on const? For a long time, it was ambiguous as to whether or not a templated exception was evaluated before or after the template evaluation. And it goes on in a lot of language. There's special cases. The Python language is supposed to be concise and powerful. So you don't have a lot of special cases to worry about, and a lot of it flows out of some very basic, you look at it and you can always tell what it's doing. We're going to talk a bit about how that works and sort of what are the key pieces. You'll find you almost never get an interview question in Python that says something like, so what does this piece of code do? There's no gotchas there. Until you get to Python 2 and 3. Okay, so moving away from, this is this greatest tool ever. So when do you use Python? Well, I think to talk about this, there'll be people who say everywhere, but it's a tool. Now, there are going to be times that you can't use this tool, and there are going to be times you can. To understand that, you have to know a little small piece about the whole architecture, and that is Python is an engine. It sucks in Python files, libraries, links to C and other resources where Python is controlling the resource. And it sits there and it runs its sort of execution side and does stuff. Now, this means it takes a moment for it to start up. Also, like an engine integrated into an automobile, it doesn't do so well trying to rip it out and shove it someplace else without a whole bunch of infrastructure. So there's lots of places that you would love to use Python. And forgive the cluttered slide here. Standard machines, they're great. You want to go ahead, you've got some sort of project where developer time is your main constraint, and you are running on a laptop, a server, or a small machine that's a full real machine like a Raspberry Pi. You've got memory, great. Something more deeply embedded or a strange machine, if you're trying to run Python on a GPU, it's not going to work. Just the assumptions about the processors are too different. You cannot do GPU well on Python. You can't run it on a smart card where the processor doesn't do this or that. It's got to put this big engine in. And because this big engine has to be on top, it has to be run by the operating system and control its own resources. This means you will never be able to run Python well on the phones or as the executable code in a standard Chrome browser. When you write systems that are going to try to work on that, they have to be much more liberal about suddenly starting up or much more liberal about suddenly getting some resource, treating it politely, and then handing it back. Python tends to hang on to things. Python takes a while to start up that VM. It also means if you're really big into fast start microservices, you probably don't want to use Python because, again, it can take a second to start the whole thing up. But, that's fine. We've got a tool that leaves for everything else. It's great for IT applications, education, scientific computing, all of these spots where you're writing an application and you're running it. So now in the land without code, we're going to move off to the things that aren't so fun. And that is when we talk about Python 2 to Python 3 migration problems. And everybody kind of groans, going, oh, God, not that. Python 3, it's great. It was released in 2008. That's 9 years ago. At present, its adoption is about 50%. It included some pleasant syntax tweaks, changed a bunch of defaults around. They said, well, if it all goes well, everybody will just move their existing code over to Python 3. Then reality set in. You can't move your Python 2 code to Python 3 well. New projects will start in Python 3. Old projects will continue in Python 2. Switching was hard, and people did not perceive any benefits. And here's why it's so hard. Let's take a look at so the land without code has a little code at the border. So up here, this line is about a little calculator program. Oh, I see this symbol. I'm going to divide this number by that number. You got it working. It works in Python 2. Everything's great. You're going to try to convert. And it just won't work because the meanings have changed between Python 2 and Python 3. The meaning and contract of what division is changed, as well as many others, but division's easy to see. In Python 2, when you divide integers, you get an integer. In Python 3, you always get a float. If you want to make this code somehow work, you have to do all sorts of your own manual checking, or you have to write your own special division routines. But to understand that there's even an error, you really have to grok what the users need, what the program's supposed to be doing, and all the errors are silent. It's really hard. You can't tell that you got the wrong answer out because you can't even port your tests without really understanding what the user meant. And so you get this sort of table of woe about trying to move from Python 2 to Python 3. They really are different languages. They have different promises and different assumptions under the hood. And you're always dependent on some tool or some library, which may have been ported to Python 3, may have been ported to Python 3, but in some slightly different versions, or less tested. And if you're going to make that switch, you sort of have to like cross your fingers, switch it to Python 3, and pray. Because of things like that division, you really can't run the same code base in 2 and 3, unless you're sort of doing it as a way to try to find all those errors and slowly ramp it up. And what you'll find is that there's not a lot of benefit to making that switch. It's a prettier syntax, it's a nicer language. But if you've got a large Python 2 project, you're stuck on Python 2. And so you end up with this big wall. You've either got people working on the latest version of Python 2, 2.7 something, or you have people working on Python 3, at least 3.3 or above, usually the latest version. A few companies are stuck back on things like 2.5 and 2.6, but for the most part, you've got this wall, and they're different countries. You can put different projects on different machines, but you're not going to make that spot. So you want to say, well, why would you want to rewrite it? And there's no commercial reason to swap over that wall. If you're in Python 2, you're in Python 2. If pushed, you can push your development teams saying, oh, we're going to switch. And what they will do is they'll say, oh, yeah, we're getting ready. We moved over all the print statements. We're preparing. One day, we're going to make that big jump. We're starting to learn the other language a bit. It's never going to happen. Because the moment they ship, there's going to be a million bugs that your users are saying, hey, the calculator stopped working. How hard is it to make the calculator work the same way as last week? Or more likely, it'll be something like, yeah, so I installed the new version, and I ran the forecast, and the forecast numbers are different. And, well, it takes a PhD to even understand if the forecast numbers are right. But I think that they're different, so one of them's got to be wrong. So you're not going to rewrite. You're stuck. So that's the world before we get into code. And it's going to be, there'll be opinions, and you'll come up afterwards and hassle me with opinions. But what's yours? If you're on 2, you're on 2. But, this is the world without code. Next we go into this other world full of code. And this is what you normally go through when you learn a class on Python, is you start learning all the syntax. I want to show you just a couple of what I think of as key ideas about the syntax so that all of the other syntax falls in line. And the first item that we're going to look at are called dunders, or double underscores. So they are the engines of Python. It's moves. So dunders are the engine of Python. They're how you interact with that big, powerful machine that's running under the hood. And so, if you sit around and you say, oh, let's spot the dunders. You say, OK, well, what's the dunder here? Well, that's a private function. 2 underscores in front. Well, that's another mangled private function. You get conventions. Double underscores before and after are either as variables or as method names and occasionally file names. Those are always symbols that this is a special thing called a dunder, and it is always used implicitly, not explicitly. This is how we do things that we take for granted, like I'll write something here. Oh, I call a new presentation object. The Python engine takes over And part of the engine saying, how do I make a new object is, I go down and I look in that class and see if there is a double underscore, a dunder init function. And if there is a dunder init function, then I do something differently. Nowhere in your code do you actually see it ever say double underscore init. But that's how we make a constructor, is that it looks for it. It's how we make equal operators among our own objects. We look and see, is there a double underscore equal operator? If so, I can do equality operations. I can do array lookups by looking for another item. I can tie into the syntax of Python as to whether or not something is an iterator that I can pull objects out of, or whether I can use it as an array context by looking to see if certain dunders are defined. So when you start looking at a lot of the syntax and say, well, how do I make my code much easier to work with? It's often, well, I add dunders in the place that it makes sense, that are the general contracts that Python has with how things are used. A context manager is often used for, say, opening a file and be sure that within this file at the end it gets closed by calling its dunder exit routine. And if you're doing something different, like, I don't know, arm the nuclear bomb and be sure that it goes off when it leaves scope, well, then you'd write it this way. So you say, why would you write dunders? So that you can use the Python piece, and it makes it nicer and easier for the people who are using the code that you've written. You can write a routine that says, check if greater, and call it with 2 arguments. But it's a lot nicer to put a dunder greater than sign function and just use the little syntax that's built in. It keeps you from cluttering up the syntax, so even when they're using your piece of code, your library, your API, it just looks like regular Python. So you think, oh, we'll write dunders for everything. Yeah, you look at your code. If it makes sense for what the Python idea is, like, oh, I've got 2 shapes, and if you add them together, well, they're joined into, these 2 items are clipped together into one big shape. Oh, okay, you just override the plus sign. Oh, I have this car and that car, and I want to say they get in an accident if you use the plus. That's not what it means. Don't do that. Don't make up your own entirely new dunders for your libraries, because the whole point of a dunder is it's called implicitly. It's hard to trace, but there are only a certain number of them within Python, and they all relate to, oh, well, now we're doing for loops. So that's one side of how Python is customized and how a lot of these pieces work, is they go and they look for those double underscore items. The other piece of Python that's important to understand is the pile of syntactic sugar that really just translates into something so that you can fit it in your head. So we're going to go off to Sugar Mountain here. It's a huge pile of sugar. Python has lots of syntactic sugar constructs that just to make your code clean and concise. But when you look at the sugar, you can often say, well, I know what this really translates into. And you'll be very close to accurate. Here's an example. This is called a, to look it up now, ternary operator, the conditional operator. Say yes if you agree, else no. Might be more concise. There might be spots where this is the right way to write your code. It really translates to what's down below the line. It's cleaner. It takes up less space. It might be more concise. But you can think about it when you're trying to trace through and find out what's going on, or you're a little lost. You can think about it in an expanded form. If you look at something more complex, like here's a method call from some instance variable. Well, it turns out Python doesn't have to have a lot of actual special things for classes. What it's really doing is when you say, oh, we'll call drive on A, it's going back to the class and finding that function And it's passing a as the first parameter, so that'll fall into self when it's actually called. And suddenly, when you're getting into something weird and maybe self has changed or something like that, you can reason through what happened. Now, under the hood, it doesn't actually do this. It usually drops a few opcodes and is a little more efficient. But it's good to know what's going on, and it always lets you go through. When you've got a bug and you don't know what's going on, you can translate it back to that sugar. So these are a couple of pieces of the Python code. This is how things fit together. If you have those sugar and those dunders, now you know how to make your own iterators. You know, how do I make an object so that I can walk through and ask for each item just like I can in an array? Well, you have to have the following sets of dunders, and you have to recognize that the syntactic sugar for walking through it is really going to say, well, first I called this, and then I called the next routine, and if the next routine throws that, then I know that there's a problem, and otherwise I can sort of unroll it into this sort of long, unwieldy loop until I know what I'm doing, and I can put these together. But the syntax also helps you think in slightly more concise ways. So let's go off and stop at the land of decorators over here. Decorators! They're those crazy @ signs. They grant superpowers. That's their job. Here's what a decorator, cowbell. The @ sign says we're going to be using the cowbell decorator on this function hello. So the decorator function is cowbell. The function to decorate is hello. The decorated function, after you've added this superpower, it stays hello. No Superman, it's always Clark Kent. So we just keep it. And we're going to, again, we're going to take this function, we're going to add some new superpower, the cowbell superpower. Now, this is actually syntactic sugar. What we're really doing is first we're defining the function as normal, and then we're changing, saying, oh, whatever that old name was, cowbell's going to return a function and make that the name instead. Cowbell is taking a function, returning a function with a superpower. Here's the big, long, complicated example. Cowbell is our decorator. This is what's going to be passed as function in cowbell. Because it's in there, inside this closure, inside this thing called def wrapper, we can call it. So when it's time to call hello, wrapper was returned and set to hello. Hello, Bob. Bob is the name. Bob gets passed to wrapper name, which then gets passed down to the function, which then actually executes down here. After it's done calling it, it says, with more cowbell. You know, it's got this new special power that it says, with more cowbell at the end of your function. It looks really kind of, weird, but it lets you do new things. And you say, oh, okay, I got it. And right when you think you've got it, there's more. Because you can have decorators that take a whole class and return a new class. You can worry about, I'm passing arguments to the decorator, so I make something print cowbell 3 times, or all sorts of other little pieces. But if you actually try to sit down with the syntax and trace through it, it actually comes back to saying, well, if I want to have something take variable arguments, there's a way in Python to do that. We have this idea of args, and okay. Well, if I want to pass an argument to the decorator, well, what function of that is getting those new arguments? Okay, this makes sense. It's usually a case of you walk through the example, and you keep going through this phase of, I don't know what's going on. Oh, it got easier again. Python is the only language I know that after you've been using it for a while, the language gets simpler and simpler in your head. And you say, well, why would you use decorators at all? When would you use decorators? And the answer is, decorators are for superpowers. Decorators are when you are adding a new functionality that is unrelated to what you're decorating. Classic cases are, I want to add a new functionality for caching. okay, if all of the arguments are the same, and I've seen this before, just return the old return value instead of calling the function. We can do that. We can write a superpower for whatever function it is, it doesn't matter. It's unrelated to the function we're decorating, and it does that. Another side is you might have something that says, oh, you got to be logged in to call this function. I'm going to go off, I'm going to check this thing, and if you're not logged in, I'm going to do that. Otherwise, I'll call the function. Well, that's great. That superpower doesn't matter what we're doing. And we can just stick one line up in front of the function and say, oh, yeah, this function requires people to be logged in, or this function requires somebody to be root access, or maybe it has an ACL, has to be level 2 or above. Those are functions we can write as decorators. They add superpowers to anything we call. And they become one of the pieces in our standard toolkit. And after a while, you say, oh, this is just Python. If you untangle it, it's sort of the simpler version of Python with a little sugar. So we've got these dunders and sugar. And that's how everything in Python is fitting together. That's kind of the core piece of how we get this nice, concise language. And underneath, there's something that's small enough and easy enough to reason about that it fits in your head. Now you can go and you can take some classes on, what does the print statement do and what does it take for arguments. But it's still going to be doing this type of thing at every step. So let's walk away from the whole line of code, because this is a very fast journey through a lot of Python, and we're going to go into the land of libraries. We're going to talk about 3 types of libraries and the different risks they have for your project. We're going to start with the standard library, the batteries. So Python says, oh, the standard libraries, batteries are included. And what does that mean? It means that if you start up and you set up with a programming language and you start playing around with it, there are some things you kind of expect. You expect to be able to read and write files. You generally expect to handle XML files, zip files, encryption, send HTML requests, and so on and so on and so on. If you wrap it up, there's a long list, and there's about 200 libraries in the standard library that just handle these things. These libraries are stable, they're tested, and they ship with every version of Python. So you can utterly rely that they're there, and your project is not taking any risk when somebody says, oh, I can use the JSON parser built into Python. Yeah, you can. It's there. To pick one at random here, I'm going to pick the zip files. It's a standard library to work with zip files. It will read and create and handle all sorts of the .zip files like you'd expect. It's about 400 lines of documentation going into gory detail that you can skim through, and you won't be surprised. They'll say, oh, it can throw this error, the zip file's corrupted, and watch out for this thing that zip files can do. But it's kind of boring, and it just works. And you can be sure it's going to be in the next version too. They might add a little handy feature or something, but it's really pretty stable, and it's been stable forever. And I would have to say, I can't tell you whether this is Python 2 documentation or Python 3 documentation. I can't even tell you if it's changed since I last gave a Buzzwords talk 10 years ago. So that's the nice, wonderful world of stable libraries. Then we go across the river and we hit the cheese shop. It's exactly the opposite. Call it the cheese shop. Technically, it's PYPI, not to be confused with PYPY, which is, well, I think they're going to rename it back to the cheese shop now. At least Titus wants to. Not to be confused with the Dead Parrot sketch. That's what the other one is. It's the cheese shop. It's got everything, probably, somewhere, except we're out of that. So there's 100,000 libraries listed in the cheese shop. Some of them are vibrant and well supported. It's like almost everything else in open source. You really have to look at it. Often when you get to a convention, everybody's sitting around saying, so, yeah, what do you use for interfacing with old Corba systems? I know there's 9 libraries out there. Which one actually works? And that becomes kind of this dance, and that's true for all sorts of open source pieces. Now, some of them are vibrant and well maintained, and are just pieces that work. So when you're picking them for your project, you sort of notice, but if it works for you, it probably keeps working, unless it looks like it's going away, unless you call up the author and say, how about I hire you for 20 hours to fix something, at which point they'll probably say, oh yeah, no problem. But that's kind of where the world looks like. And here's an example. This is Flask, is one of the libraries here. It's a good, solid library in the Cheese Shop. It's a little micro framework. You'll find it in the Cheese Shop at PyPy. Or you'll find it on GitHub, or Wikipedia, or read the docs, or GitHub. I mean, it's everywhere. But it's a simple, lightweight way to serve web pages. So it's a library. You sit there and you read some documentation, and in about 5 minutes, you've got something serving something. And if your real job was to throw a quick REST API onto some large block of code, it'll work great. If you want to scale it up and run Twilio off of it, well, that's what Twilio does. But, you know, it's a good, solid piece. It's been around for at least 7 years. They've never bothered revving it up to 1.0. You know, it works. Everybody says, well, we'd like some improvements. What? Well, I don't know. It just seems like it's been a year. We should improve something. Well, okay. Are there any bug reports? Nah, we killed the last one 3 years ago. Okay, well. Eventually, nobody will change it, and it'll move into the standard library. Maybe. But as it is, you know, there's a nice little library. And then there's a third type of library that I want to just mention because of the project risks. And these are the adapters. So we had the batteries that are simple and stable, the Cheese Shop, which is, you know, keep your eyes wide open. You never know what you're getting. And they're the adapters, which are safe if you're careful. Python's a popular language. So pretty much every piece of large code out there, somebody's written a Python interface to. Now, different levels of how well they did the Python interface. You can sort of automate it and run your C interface or other language interface and computer generate a routine that, you know, passes you a handle that you pass to the next step, and you can kind of get by with that. Others have, you know, what you'd like. It just works like everything else. They bothered making some dunders in there, and it iterates just like everything else. The two big risks are when you're going to use an adapter, check the licenses. The license adapter may be different or more restrictive. You may suddenly find that, well, this is BSD open source with a GPL license on the adapter. Great. Just check that. Also, watch for dependencies. Often you'll see this adapter, and in the fine print it'll say, oh, and there's this dependency. I hope you don't mind. Like here's one. This is OpenCV. It's a huge image processing library, originally built by Intel in Willow Street. It's BSD license. The adapter is BSD license. It does all of this. Oh, I take images. I find your face in it. I do recognition. I do blurs. I do everything you'd ever want from an image processing class. And it also says, oh, by the way, we need the NumPy dependency. Well, that kind of limits your choices. And if you want to know why it limits your choices, it's because NumPy is part of a mountain of code. Which means we're going to go into the mountains and look at mountains of code. So here we have mountains of code. This is what happens when projects grow up and they really want to get big, is that they slowly accumulate more and more people and sub-projects, and they start getting these trappings of a mountain of code. So trappings of a mountain of code tend to be things like they have their own conferences. You find a dozen or more books on Amazon about how to use this. You have hundreds of thousands of lines of code. When they list contributors, they have to break it into pages. And there are several of these out there. Actually, I would say probably about a dozen. I'm going to pick two because, you know, it's a short term. But these are mountains of code. When you pick one, you're locked into that mountain. You are able to use little libraries, but you can't stand on two mountaintops unless the developers have done that for you. If you try to make it so that you can merge these two mountaintops and use mountains of code and use them together, congratulations, you've now become a maintainer, and this is what you're going to be doing. And people will be saying, oh, that's cool. This was going to be a lot of work, but somebody else did it. Great, it just works. So let's take a look at the first mountaintop over here. I'm going to call it, this is the mountain of SciPy. In practice, it's really a mountain of open source scientific computing. But SciPy is its own distribution. You instead of going to Python and downloading Python, you go over and you download theirs, which has a bunch of sub things. They have NumPy, which is that dependency I mentioned for OpenCV. Well, NumPy changes things. It changes your contract about arrays. It does some really cool things about arrays. It's enough that I could give a whole talk just on NumPy, and people do. Go to one of these SciPy conferences, and they'll have a talk on NumPy. And they have their own library that ships with it, because when we think of batteries included, and you think of batteries included for scientific use, you might think of things differently. I mean, in science, the first thing you do when you pick up a language is start running. You have to be able to run linear regressions, and you have to do statistics. And if it doesn't have a basic data type for time series, you're kind of confused. You want to have it do manipulation of multidimensional and sparse arrays in very efficient manners. Well, we do that with things like NumPy and SciPy. And it's got a lot of really nice plotting tools that are just integrated in. And so SciPy originally was this sort of commercial distribution, fairly cheap, and now it's mostly open source. But you get all of these sub-projects that have grown up, and there's a whole community there. And so this whole community goes through, and they do all sorts of things. And so if we're doing a tour, this would be like looking off and saying, oh yeah, so that huge city down there is the scientific computing world, and moving on. So there's a lot that happens. It acts almost like a benevolent fork to Python. They go out and they make stuff, and some of it's really cool stuff. And everybody talks back and forth or is in both camps at any time. And when they come up with something cool, it gets copied over and transferred to the other people and say, oh, that was cool. We should do more of that. And sometimes people say, yeah, we tried that. Let's not do that again. So it's someplace in the middle there. But each of these is its own little area. IPython gives you this beautiful console, and pandas gives you all sorts of dealing with large data structures. If you want something where you're going to analyze your stuff in Python that's coming right off a linear accelerator and it's decided how it's storing the data, that's fine. Scientists, people worry about that all the time. Your gene reader is spewing this stuff out to you. Yeah, okay, you can deal with it. But it's what it is. Sometimes they come up with amazing things. And this is one of them. This is called Jupyter. Grew really out of this scientific computing folks, mostly out of the IPython side. And what it does is it lets you write these notebooks that are a mixture of markdowns so that your text looks nice and has boldface and real descriptions and things, as well as some controls and running code that you can then see and use. It's a great thing for open science, where people say, this is what I analyzed, and you can look at it, and if you disagree with me, well, you can run things around and try to see what else you get, and maybe we might decide that if we're not using Excel, we might decide not to impose austerity on Greece. People who know about data science will know that joke. But that people will put together and they'll build nice interactive notebooks for teaching things or for publishing their papers. and you have this nice piece that looks an awful lot like IPython, because it is IPython, so that you can go ahead and just type stuff in and see the results right away. But if you don't like Python, well, it's called Jupyter because it's Julia, Python, and R. And as long as you did that, there's about 40 other languages you can write in as well. It just doesn't care. And since it runs in the browser, that means that only one person in your lab has to get the thing installed right. And it creates camera-ready PDFs, and it does this and this and this, and it's part of this whole scientific computing process. And you can start seeing this mountain kind of cleave, and they're starting to have their own conference. And more people are, piling on, and people are saying, well, this whole way of doing RVIX and open science publishing, maybe we should do, and, what about this journal will take only IPython notebooks from now on? Okay. People are working with Python to get their jobs done. And there are a lot of them. So when you walk through this small little, so that's one set of people getting their jobs done. Let's continue on from the scientific community and sort of wave at the Django community over there. Now the Django community is another one of these large cities. It's got its own conferences. It's got the dozens of books. It's got its own concerns. So where the scientific community is part of the open science groups and large groups that are working with all sorts of open source across all sorts of platforms, the Django people are often working on, we got to get performance. You go to something about how to program Django with Python, and the second subject is how to configure memcached for higher performance in certain types of websites, because it's important to that group as people get their jobs done. So Django serves web pages. It serves a few other things, but basically it serves web pages. It does it up to very large groups, very secure groups. So a few of the things offhand will be things like the Washington Post or Pinterest or Instagram. Those just run on Django. Yeah, you can scale this stuff up to really, really large. And there'll be an army of people writing all the little pieces and parts, and then an army of people just sort of moving around and taking out pieces that were originally Django's good enough solution to something, but with the bolts, so you can put a rocket power in there if you need to. It will end up as its own little world. And it's really good at serving large amounts of web pages. So on one side, we had Flask in the last section. That would kind of let you serve web pages. Didn't care about DOS attacks. It barely cared about staying up. But hey, it worked fine for when you're writing your own little project. All the way up to this whole ecosystem over here that serves really large web page systems for top 100 sites. And they are developing cool things. And a lot of what they develop, they're the first people to really come back and say, yeah, that Python to Thrina migration we have all the following problems with, because they tried moving a very large code base over and found they had to touch every single string. That these people are working on their world of performance monitoring systems, caching, systems administration, schemas, migrating schemas on databases underneath you in Python, while the data model that you're presenting to other parts of your application only changes under certain cases, and how do you shard these things up? And that's a world. So when I look at this whole journey that we've been talking about for about an hour, we covered a lot of ground, but we also didn't. We covered a lot of ground and very little of what Python is. The biggest thing to take away is these are all people trying to do something that they want done. And if what they want done is that they want to sit down and teach their kids about graphics and programming, well, hey, the standard library has a full Turtle graphics system in it someplace. You should look in the standard library if you just want it to work and you don't want to mess around with installing anything because maybe we don't know all that much. Or maybe we're teaching a math class, and we want people to try things. Oh, well, maybe an IPython notebook would work better, or a Jupyter notebook. Or maybe, we'll have people putting in their data and we'll be plotting it out. There is a large community, and you're not alone in whatever type of problem you're working on. You can find people who are working on those problems and who have been working on them long enough and hard enough that they have pieces of your problem already solved that they can share with you. So it's a large enough community that there's a hold for whatever it is you want to do. You can solve your own problems in Python, and it can be fun, but it's not always necessary compared to going out and saying, what part of my problem is general? This is a little like every venture out there saying, oh, well, what's my value add? Oh, well, we're going to be the first people that handle 3D chats and put furry animals on your head. Okay, that sounds good. How do you work with all the cameras? No, I don't care. We'll use NumPy. Or we'll use OpenCV because it has interfaces for every camera out there, because a lot of people have that problem. If we find a bug in it, we'll fix it, and then it'll go away and be gone in all releases. But you can focus on what your own problem is. It's a big community. There's a lot that we can have fun with. And it's still just a fun language to get in and play around with. Almost all of these libraries, it's like, well, I could read the documentation. I could just say, oh, is there an open? Yeah, okay. Can I display it? Good. Wonder what it does. Don't do that. Okay, well, I can do this first. Oh, now I've got, I did something. And, you can do 6 impossible things before breakfast. It's going to be fun, and you're not alone in these journeys. So thank you. That's what I really wanted to get across. Thank you. I can take questions from people and things like that if you'd like.
Thanks a lot. That was great. I'm really excited now. Go home, code some Python. Well, maybe I'll sleep first, but.
No sleep. Sleep is for the weak.
Oh, okay. Yes, sir. Anyway, does anyone have questions? If so, there's a mic there. It'd be great to.
Hello.
Is this work? Yeah. Good. So thanks for the talk. I had a question. When you talked about packages, Cheat Shop and others, there's a proliferation of packages, and I was going to ask you, what are general tips on how to find the package that actually does what you want? So some of the things you mentioned, like licenses and dependencies, they're not the number one issues. The number one issue is the package doesn't work, and it doesn't do what it says it does. And it's buggy. So I have a specific example.
Other people are going to say, oh, first it's got to work. And then there'll be people like, no, we can't touch it if it's got the wrong license.
No, not talking about license. I'm saying it doesn't work. So here's a specific example. Anybody who's used NumPy and Pandas, and I know the answer to this, the answer is there aren't any. What is a package? If you Google for this, you'll find tons of packages that claim to offer compressed integer arrays that include nan. So even if the only values you can have are 1, 0, and nan, or int 32 and nan, there is no in-memory compression package that will actually do this. There are tons of packages that claim to. It's really hard. I actually wasted a few hours on this once before giving up and realizing that.
I think your question is, how do you find this stuff when? Sorry, let me go. Just leave up.
Maybe.
But the issue is, how do you find this stuff? And I'll give you a couple of quick tips.
No.
What's your question?
The issue is, as I said, when you Google for a certain package, you will find 5+ packages claiming to do something. Many of the times you look into it, you download the package, it doesn't work. There's no mechanism to -1 this and say this package is wrong, the author's exaggerating, or they haven't implemented stuff. Sometimes the package is a skeleton. What is the mechanism to actually find out
so to
a package that does that sort of thing?
There's usually a few things. First, like almost everything else, if you've already developed a community working in your own exact space, ask them. Somebody else has also gone down this path. Otherwise, this is the way you find where somebody says, oh yeah, pandas. Pandas is part of SciPy. It's a standard thing. But how do you find out what it is? Well, you could go to the website. That's going to take you a long time. Or actually what you do is you go to SlideShare and you type pandas into the SlideShare. And it's anything in the last, say, 365 days. When you want to look for, when there's 9 packages and only one's well supported, what you usually are going to find is that there are 20 presentations for the one package that generally works and is generally well supported. And for 8 packages that don't work, there's not going to be any presentations. If you go through if the package that everybody likes doesn't actually have that feature, then it might not be there, and you have to actually go do it. And if you ask around a little, what you'll often find is people say, yeah, there's this discussion thread, we thought about it, we figured out all the nuances, or I'd love to get a pull request from you. So you go and you do it, and they say, oh, great. And if it passes everybody's reasons for putting things in and out, and don't ever be upset that when you submit things to open source, until you're a regular contributor to a project, things randomly happen. And it's not you, it's not people having criteria, it's just these people are doing open source for their own reasons. I actually got banned from a project because I'm old school. You know, when I type a period, I don't even think about it. I put 2 spaces after the period. That's how I write documentation, period, 2 spaces. And the second or third time that I went in and they said, oh, this is a great 3 pages. Oh, and we had to take out these spaces. They just said, you're banned. You put spaces after periods. It's HTML, dude. They go away. Doesn't matter. And besides, I'm having a bad day, so I wanted to ban someone. You're it. I mean, so don't ever feel bad about you try to contribute the first couple of times and stuff happens. But yeah, sometimes you look at these packages and they're just not there. And the closest you can have to a -1 is just to ignore it from then on. If you've actually bothered looking through 5 or 6 and you write down the nice blog post, then the next time the person does the Google where they put in, and we've all done this, you put in the name of what you're looking for and the name of 3 things nearby to see if you can find the article that compares them. Yeah, then maybe they'll find it. But it's not a magic. Can you go ahead and get the next person?
Right, but in the specific case where a package author claims to support something and they don't, it's
Talk
all
to
cool.
them.
No, I'm trying to say, the specific example I give you, I have, I'm dealing with pandas. I don't want to allocate 48 bytes for every single logical.
Let's chat about this offline.
Yeah, I'm just trying to say there isn't really. It's a legitimate criticism of Python that there are a lot of package authors claiming to do what, and the stuff doesn't work. And the answer in some cases would be, don't use Python on this, use R, or install H2O, or write your own C Python.
Okay, let's chat about this offline. Okay.
So, awesome talk. I realize this may or may not be a beginner question, but what is your thoughts about running Python code outside of what I would call it the Python compiled runtime? So like using Google's new project that they've released called Grumpy.
Okay, yeah, so Grumpy is, in case people have never seen it, I expect most people haven't, Google is playing around trying to mix Go and Python. What you will find is that just like there's this ecosystem with, say, the scientific Python community feeding back to Python, a lot of these other languages are feeding things back and forth, and people love writing in Python because it works right. So Go, there'll be spots where people are trying to kind of push syntax into it. I think that it's very easy to write something that does sort of Python-ish stuff, especially if what you're really after are chunks of the Python syntax sugar. But you quickly run into very odd cases that can show up. In Python, if you want to be really mean, you can do things like halfway through the loop, then I add an equality operator, and now you go to someplace else when you're checking equalities in the middle of your loop. There are many people that are programmers that should be shot. But no, I think it's a fun thing. They'll learn something about it. if Python is controlling its resources, then you can run Python on almost anything, but it's this big engine. There have been different attempts of different things of stripping out chunks of Python. There are also lots of variants that are almost, but not quite Python. For example, PyPI, or the dead parrot, is a system that allows you to speed up Python a lot. It's great. It does a lot of JIT. It does real garbage collection instead of reference counting garbage collection, which means that it's on average a lot faster, except when it goes away for 400 milliseconds to do something. This is a trade-off. If you write your code and you write a dunder del function, which most people would find reason it's what's supposed to happen when it's garbage collected, yeah, those won't work. And if one of your libraries has one, it may crash everything. Things that are counting the references, it might crash everything. So if you're writing for this PyPy speed up, you end up sort of standing on this mountain, and your code now works on this mountain. And that might be a very valid trade-off. These things like trying to run Python on Go, mixing it with Go, great. What it actually looks like, I can't tell yet. I think that the big thing that happens is there's a lot of Python. There's going to be one more big language after Python, I think. And maybe I'm an old man and I'm hopeful. But the C syntax kind of took over the world. It's always int, not integer. The Pascal syntax kind of died. If we go back far enough to just before my time on this, there were 100 different assembly languages, and then somebody made what was called the last assembler. And it was. And it just read in a data file, and it had a consistent, flexible interface, and it didn't, it's not like, I think it was Cyber, you had, well, these columns of the card are a label, and those columns mean this, and these columns, no, this was just it's just text. And it works, and if you want it to work on the Cyber, you tell it, oh, it works on the, here's the little Cyber file that gives you some hints as to how to make that. I think in languages, we will come up to a point where we will start explicitly doing things like frozen classes, where we say, you may no longer change the internal dictionary of the class. Have a nice day. We already have Python. There are some areas that we haven't really looked into. You can turn off the ability of Python objects to actually update their own dictionaries. This sounds a little weird, but if you're making a whole bunch of little objects, instead of having this dictionary where I can add any old value because it's so convenient for the programmer to just add any old value, you say, no, these objects are going to have an X and a Y and a color, and that's it. Okay, and now we can speed that up, and we know how big it is, and we can do all sort of small block memory management on it, and it'll run faster, and those are called slots. It speeds things up. And the first thing you do is you learn, and you run the profiler and say, oh, I didn't care anyway, because we'll get past that. So that's what I think is going to happen with Python Go, is they'll learn something, and then they'll go off and they'll sort of rev Go a little to have a little bit nicer syntax in some areas.
Cool. Thank
Be
you.
more fun. Yeah.
So I wanted to bring it back to one of your first slides. You talked about the Zen of Python, and one of those is there's one natural and correct way to do it. We have two versions of Python. We have a couple of different mountains here. Mm-hmm. Do you see this as a strength? I mean, are we going to have the IPython folks be entirely separate? Do you see this being trouble for beginners? Do you see?
I think that the mistakes in the Python 2 to Python 3 migration are going to be legendary. The issues as to why there were their mistakes are very human. I mean, I and others were arguing with Guido saying, you got to give us the U in every version of Python. For the first few versions of Python 3, you couldn't put U in front of a string, which meant that you had to touch every single string in a large code base, and you couldn't try to kind of do that and sort of get ready for a transition. There were issues. I think that there will always be separate mountains. There will always be a lot of spots where if people are friendly and productive, we are learning things from them and they're learning things from us. Think of how fast Python evolved when Ruby and Perl were both evolving well too. You know, there's spots right now, I don't know, how many people here program in JavaScript as well? Okay. So if you program in JavaScript and you're working with the latest versions, you'll find there's some really nice things. Like I can take a return value and instead of like just doing a tuple unpack, I can take a dictionary unpack. I kind of like that. Wish I had it in Python. So that I can get back this, instead of creating a separate return type class, I can just say, oh yeah, here's the value, here's an error message, or here's a value, here's some secondary token, and maybe there's an error or not, and if so, I pass it back. And I can just have this one line that just deals with it. Or another thing that shows up is they have a nice way of, yet another print formatting hack. They have you escape out to only local variables, gets rid of most of your security concerns, but gives you a nice clean way of handling it. At some point, I'd love to do a Python 5 gets shipped talk, maybe in a few months at least. But we'll give a Python 5 thing, and I will totally make up what's in Python 5 and say, look how great it is, and now finally we can get off of both 2 and 3. So
Thank you.
I hope that answers your question.
It did.
Kind of building on that last discussion, have there been learnings on that transition? Has there been something put together that says, we won't do this again? Here's how when we come out with Python 4, here's how we're going to do it so we don't make the same mistakes. I mean, it seems like a lot of these issues, languages have been dealing with backwards compatibility for ages. And yet Python decided to go a different route. It was very conscious, because I remember hearing discussions when they were talking about it, saying, oh yeah, we're breaking this stuff, we know it, and it's good for you. And that was kind of the attitude.
It was the attitude. So first, let's point out that people, when they first learn about languages in college, you talk about, oh, is it strongly typed and so on. But they don't always talk about some of the key issues. One key aspect of a language is how often does it make incompatible changes. On one side, you get things like C#. Anybody here program in C#? Which version? Okay. My understanding, and I could be wrong because I haven't touched it in a while, is that on a very regular basis, people come together and they've thought of all these great ideas and they make a new version of C#, and your migration path is really simple. Oh, what do you have, a project in version 4? Yeah, you write that on version 4 and you run it on a server that is 4 installed, and you have a separate server that is 5 installed. And never the two shall meet. We don't even bother. And that's a choice. On the other side, you get things like C. There was a big change back 15 years ago when they finally added some things and made them required, and people aren't sure that was a good idea. I know of one of the top 3 banks ported the main piece of code that actually does all of the hairy banking up to COBOL. They weren't sure they got their money's worth, but they figured they'd better be on a slightly more modern language than it was. Their solution for maintenance of this is that they had 3 people who were the original programmers that were still around and had no other duties except not to all drop dead at once. And every now and then, the law made some minor tweak, and they would think about it, and they'd go in and they'd change one line. And it was worth it to the bank. And then they had a whole building of people putting nice GUIs on it. So how often a language revs is a problem? I don't know if they're going to change it. In Python 2.3, one of the core aspects was that the core development team was kind of burnt out, and without letting them sort of have their head of, oh yeah, I insist this is the way to do it, they might not have ever had a Python 3 or a Python 2.7. It's a trade-off we don't like. We can talk about it. I think if I were to say what I would like ideally, if we go to a Python 4, I want Dropbox to convert completely to Python 4 before they release it. Somebody should pay the price on a big software first. and it shouldn't be me. Okay. Any other questions, folks? Well, thank you so much.
Thanks. Does anyone have any last-minute announcements or anything? Anyone?
Hi, I'm Vicky. I've been working for an underfunded startup for a long time, and I think I need to find a job that pays money. So if you're hiring, come talk to me.
Anything else? Well, thanks everyone for coming. Thanks.